So this tool is going to seek to address a problem that everyone who operates a lathe has, and that is to line up the cutting edge of your tool with the cutting axis of your lathe. And if you are off axis, you can have your part try and climb on top of your tool. You can have premature tool wear and breakage. So a lot of times, not always, depending on the tool, you want to be right on center. And getting there can be quite challenging. One of the common solutions is to bring your center up to your tool, then attempt to line up your tool, the point of your tool with the point of your center. But being a point, it's a very small point in place. In mathematical terms, a point has no length, width, or height. In reality, obviously, that's not the case, but it's extremely small. So getting them to line up is very hard, and the closer to dead center you are, in a lot of cases, the better cutting action you'll get, and the fewer problems. So this method is one. It works okay for a rough estimate, but I find it very difficult to get it right on. Let's look at another approach. So the next approach, the one I learned in school, involves taking a tool that you always have close at hand, or most people do, which is a rule, and placing the rule between the point of the cutter and the workpiece. And you will notice that it's tilting significantly forward. So as you adjust the height closer to center, I'm just going to rough it, then the rule being pressed between the work and the center will, when accurate, go to perpendicular. So right now I've gone a little bit over and now it's pointing the other way. So if I drop it a little more, that's roughly centered right now because the rule is vertical. There are some problems with this method. One, if I have the cross slide applying 10 pounds of force on this carbide cutter, and the very point of the carbide cutter is 1/1000th of an inch, I will effectively be applying 10 times 1,000 or 10,000 pounds of force on the very tip of that cutter. Pounds per square inch, which is extremely high and makes it very easy to chip your cutter. Also, there's a second problem with this, which I'll show you now. So the second problem was when the diameter of your stock is large, because the window of error increases, because the curvature of the side becomes closer to it approximating a line. So as it approximates flat, the less deflection you're going to see in your rule. So I have thrown my cutter way off center, and you'll notice there's only a slight shift in angle. And as I move the cutter up quite a bit, it gets harder and harder to tell whether the cutter is exactly on the axis or not. So Joe Pieczynski in his video has given us a third way to do this, and it's really straightforward and really simple. I will be providing a link to his video, and the only reason I am going over this is because I want to make the tool that he demonstrated. So since my videos are all about making tools for the most part, I thought that it would be fun for me to make one, and it's a very useful tool for me to have, and at the same time I might make some variations on his design. So Joe's solution involves the ground part of the ways of the lathe, and what he did was he created a piece of aluminum that was exactly the height of the center axis of the lathe. Then he cut a milled A flat into it so that you could bring your tool cutter up while leaving the aluminum on the flat of the ways and line them up and get your height right on. So the next step, if you want to make this, is how do you exactly find that height? I have a 14-inch lathe, so you might think it's exactly 7 inches, but it turns out that it's not. So the next step is to find the height of the center axis of the lathe. Copying Joe Pieczynski's solution, I have got a gauge pin in here that's a half an inch gauge pin. And if I look for the high spot, it's pretty close to 0. It's really touchy. This is a 1/2 thousandths indicator. So if I set that at my 0, then I've built a stack of gauge blocks here. That also reads 0. So now all I need to do is I need to take the stack of gauge blocks, add them up, and subtract a 1/4 inch for the 1/4 inch that's above the center axis of the 1/2 inch gauge block. So you can get a better view. So that's all I did. So you can see it's really close, within a 1/2 thousandth. And there's the high spot. There's the high spot on my gauge pin. So when we're done, we should be able to get this within a 1,000th or so. So now that I have a height, all I need to do is cut out a block that's very flat and parallel, and that I can set on the flat part of my ways, which is right here. So the flat part of my ways, and then I can set my tool height based on that. Alright, so this is some 1 1/4 inch aluminum stock. My first task is going to be to rough face the bottom so I can center drill it, because what I want to do is I want to extend this material out enough so that I can dimension it across its entire length, and so I'll need the live center for that. So also, it's going to be very important that the bottom be really flat and parallel with the vertical surface. So that's why I'm only rough facing it right now. So at this point, I'm going to center drill the end of the part, which will be the bottom, just to hold the live center. That should be good. So this first pass is going to be a really light pass, and it's just to make it round essentially, because what I'm interested in is having a round surface to clamp onto with the chuck, so that I can then check for taper, because I don't want there to be any taper, because taper would imply that it's at an angle and not square with the base. So this first cut, I'm just taking off 5 thousandths. In contrast to the 4140 chrome moly, this stuff cuts just beautifully, especially with this positive rake insert. It's a mirror finish. Alright, so I just wanted to make sure that my part was not only round, but that there wasn't taper in the shaft. I did notice something on this with this 1-inch indicator that being stuck out like this, that as I move it'll look like it's going to be off a thousandth, but it's actually not, and that's me if I'm pulling back on the cross slide as I move it, because you can see here just loading and unloading is causing a little flexion in it. But in any case, there's not any really discernible taper, so that's good. So we can move on to facing it and drilling for a magnet I want to put in the bottom to hold it more steady while I'm doing the measurement. So we're going to drill for 15-30 seconds. So next I need to bore this out to 0.499. So ordinarily this would be a terrible idea with so much stick out, but it's very thick, large diameter, and I'm taking off very small cut and very soft material. Okay, so that last pass got it into 0.499, and I'm just going to deburr it a bit. And then I'm going to test fit the magnet. So this feels like it's going to be a perfect press fit. That's really tight. Just starts. Okay. Alright, so it's parting time. And I won't need to stop and chamfer this because it needs to mate up flush. So we're just going to part away. As I get closer to the middle, the linear velocity actually decreases and the surface feet per minute decrease. So I'm actually going to speed it up, try and keep my cutting speed similar. Got to make sure to stop periodically and break the chip really close. There we are. I also left this side about 1/10 large on purpose. So in case you were wondering why I left the overall length 1/10 of an inch larger, it's because 4 Thumb McGrew, as he's walking over to put this in here, drops on the ground and dinks the bottom, which is one of the reasons why I was a little hesitant to use aluminum to begin with, because it's so delicate. However, the ways themselves, I didn't want to risk a harder material that would scratch the ways, because if anything gets damaged, I can always make another one of these, and having the ways redone, well, that'd be expensive. So I'm going to face this side again that I bored the 1/2 inch hole. Then we're going to turn it over and cut it to length, bore the 1/2 inch hole on this side that will hold the stainless steel portion of this tool. So this next step is really straightforward, but I just wanted to mention it because I'm going to follow the recommendations of a machining book I was reading from the 1940s, and it said if you want the best hole possible, you spot drill, followed by drilling, followed by boring, because the drill roughs out the material, the boring makes it parallel to your axis of your lathe, and finally ream it to size. So I'm going to give that a shot, see how it works, and see if it does a good job. I'd like a really tight fit. Good sign. Doesn't sound like it's an interrupted cut, so it sounds like we're pretty much on axis. Alright. I'd have wanted to go a little slower, hindsight. So a little bit of deburr. And just for the hell of it, I'm going to take a measurement, see how close we are. Should be right on. I measured the reamer ahead of time, but oh, almost 1.5 thousandths over. So we'll need to take that into account when we're doing the stainless steel next. So next, I need to turn down this, about 3/4 of an inch of this. This is stainless steel 303. I need to turn down about 3/4 of an inch of this down to 1/2 inch so that it will be a press fit into the aluminum part. So let's rough some out of here. This is 1 1/4 stock. We're going to try some 100 thousandths passes. Silver, not blue, so we're definitely not pushing as much as we could. So, let's see, it's on incremental. So we're at about 0.5136. So I need to take one more pass at least. But it's kind of warm, so we're going to let it cool off before we do that. Plus, I think I'm also going to chamfer the end to make it feed into the other part more smoothly. Really tight. Won't go on, which is good. Currently 680 RPM, 2,000ths per revolution feed rate. Oh, that just starts. Yeah, it just starts. We're really close. I think I could probably fit that on, press fit that on right now. Yeah. Maybe I'll take it down just a tiny amount with sanding. Sanding removes material on the order of, well, depending on the grit of paper, of course, but with this fine a grit, something on the order of tenths. 1 to 2 tenths every time. Oh yeah. Okay, that's going to be a really tight fit. That's perfect. Leaving a film of aluminum behind it. Perfect. So I've got a little bit of a burr here. And a little bit of burr on the inside, and I want it to lie flat, not sit on a burr. That should do it. Alright, so the two sides press fit together really nicely, and now I am going to pin it. So I'm going to spot drill it, and then ream for 1/8 inch pin. Okay, so we're going to go 3/8 down from the top. This total length of the aluminum part here is 4 inches 80 thousandths. The top part is will be 3 exactly. It's actually a little long right now. So that hole's a bit larger than the 1/8 inch, but that should help start the pin. So we're going to drill undersize. See about a little bit. Sorry about the squeak, it's cold still. And we're through. Next step, pin it, and then finish to height. And once we finish to height, then I can cut the flats. We'll be back here at the mill. Okay, so I'm using a hardened steel pin, and that went in very nicely. I'm going to counterset that. This is 1 1/4 inches in diameter, so, but there you go. I will set it a little lower. It can be 1/8 inch below the surface on each side. Okay, so we're at sort of our final stages here. Right now, I am trying to get the total height of this bar to be 7.080. So I'm taking off a facing pass and then going to the surface plate and measuring, coming back. I'm taking it slow. I'm about 30 thousandths plus right now, so I'm going to take a 20 thousandths pass, go and measure, come back, and see. The problem is every time I leave and come back, since I have no way to reproduce the position of this, certainly within 1/1000th, I have to retouch off, and that sort of gets you off by 1/1000th, so I have to be really slow and meticulous about this. 20 thousandths pass. So about 11 thousandths tall. Gonna make sure I get past the chamfer. That was a little aggressive. Okay. So we're gonna take about a 7,000th pass. In case you were wondering, this was 302 stainless steel. It's an easy machining form of stainless steel. Not quite as corrosion resistant as other versions, but easier to work with in some regard. Finishes very nicely. Alright, so let's take this over the surface plate and show you how we're measuring. So I got my stack of gauge blocks back again to 7080 and then set this to 0 on that stack, and then face this until we got really close. Alright, so now we can take it to the mill and cut both sides to get some flats to have our tool measure up against. Alright, so let's find both our zeros. This is definitely not a critical set of adjustments here. This is purely access, so absolute values are not important at all. However, I would like to take off as much material on the top as possible, only because the weight of the density of the stainless is a lot higher than the density of the aluminum, so it's top heavy. So the magnet helps that, but if I can get some more weight off, it'll be even better. So we're going to call that our Z0. X0. So let's do 100 thousandths pass. We're going to take about 350 thousandths a side off. So you're not going to want to see the whole thing, so I'll just show you the beginning. Not to mention that the large depth of cut is causing a lot of vibration in the camera, so we'll skip this and I'll just show you setups. So when I flip this over, you have a problem if I want to get it exactly 180 over. What I did was I put the flat down, which actually doesn't touch the parallels, and then I used an adjustable parallel and swept across to get it flat, and that was pretty much it. So we're going to cut the other side. We're going to have to refine 0, and then we'll be done. Okay, so putting it all together, putting a tool in the tool post, placing the new magnetic height setter on the ways, and bringing your tool close. You can use the fingernail test, except in this one I can use the finger test because it's way off. So drop it down. Still a little bit. Get a little closer. Still needs to be a little lower. Nope, too much the other way. The beauty is your fingers are amazingly sensitive, and you can get surprisingly accurate results this way. And there we go. And I can tighten the nut. And we're ready. Just as a side note, running through my tools, about half of them were off, like this aluminum one. Just off by a little bit. Which probably says that being off a little bit isn't super critical, but why not be on as close as possible? So another useful technique I discovered was that for really sharp pointed tools, you can turn this to one side so that you can go parallel to the edge and get a much better surface to compare against. It also works for boring bars, which Mine is way off here. So here's the new tool in my arsenal for setting height on all of my cutters. All right.